Yeah, man. So, $500. Let's call it 500, and then 30, 30, 30, 30. So that's basically the EOMA68 project in a nutshell. Over a long period of time, say 5 to 10 years, if you buy $500 laptops, 1, 2, 3, 4, 5, the last 4 end up in landfill. Whereas if you do this project, this type of thing, you buy 1 base station, you buy a $30 a base EOMA68 laptop housing, $30 card year 0, next year $30 card sort of thing, and these end up in an ecosystem where this is now in a data center and with lots of little computer cards like the Raspberry Pi Coda hosting. And the guy who buys them from you makes €3 a month and keeps them out of landfill. The second way, so that's the one of where you've got multiple cards, because you can upgrade continuously multiple cards into one housing. And the other way is you have a laptop and you have a tablet and you have a desktop PC and whatever else it is that you want to do, a micro desktop, all in one PC with the keyboard hanging off of there, and you have one card that goes into every single one of those devices. Now you save money, you save yourself. If you've got 2 devices, you save 40% the cost of buying 1 tablet and 1 laptop. And you no longer have the problems of your data being incompatible with the operating system on here and here, because this is running Windows, this is running iOS, this is running, your smart tablet is running Android, whatever, and it doesn't happen to have the same capability or capacity, therefore it doesn't work. Instead of memory card being used to transfer the data, you take the computer card, the whole computer, and transfer everything, applications and data, and you get consistency. And also, another big advantage is you can try in the shop. You can say, I'm not sure if I want to buy your card, your new card with the super duper processor with the blah, 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 blah. Can I please try it? You unplug your computer card and plug in the new one inside the shop and test it out and try it out on your device and see if you like it. So those are the basic advantages of the modular computing approach, which Intel copied. World's first computer card initiative by Intel. Woo! Intel Compute Card, 2006, CES. Loads of distributors, so excited. And I'm looking at what they're writing on the internet, and it's like, oh, we are so excited to be working with Intel on our little micro desktop thing where people can upgrade their computers. Like, you quoted that out of my 2015 white paper. Prior art, man. Prior art, not from me, but from ICE Computers in Taiwan, 2010, who, yeah, they've got patents. Oh, but the actual concept of modular computers goes back to a 1983 expired patent where somebody put a computer, including the LCD, on a PCMCA form factor credit card size computer. So, you got patents, screw you. Sorry, anybody who's offended by that sort of thing. I'm not, I don't care. Simon Sinek, I apologize for that quick introduction there, but I just wanted to get my breath back from being a bit late. Simon Sinek says, that you should do a talk by explaining why, how, what. Not what, how, why. The one that is incredibly funny is he said, Martin Luther King did not give a speech, I have a plan. which is the what. He had a dream about why. Why I am doing this is because I am fed up with manufacturers making devices which end up in landfill, which are designed for obsolescence, designed for manufacture, not repair, and designed to provide the manufacturer with the right to shut down your entire device remotely. As happened when Google bought a company that provided an always-on home smart management system. Within 18 months, they decided that they didn't want anybody to use it anymore. They wanted people to buy the Google devices, so they remotely shut down the device, completely bricking it, claiming that it was out of warranty. So this kind of thing I consider to be highly unethical and environmentally incredibly irresponsible of the manufacturers. Unfortunately, because we do not have any choice, we, in order to connect with other people and to achieve the kind of worldwide global connectivity that we know has beneficial effects, unfortunately we're required to commit to these companies and buy their devices. Now, if you people here are technologically aware enough to be able to reprogram and repurpose your devices to the extreme extent of spending 2 years reverse engineering something just to be able to keep it around for another 2 to 3 to 5 years. I know that a lot of you have 10-year-old ThinkPads. I've seen people with the Sony Veos, the ones with the Pulse-Flow chipsets. I've seen Toshiba Librettos, and it's amazing. I'm so impressed and delighted with what you guys are achieving. What I want to do is to empower the people who do not have the same skill set as you do, to be able to achieve the same result, the same end result. So how I'm doing that, saying what, why, how I am doing that is by splitting the design into a passive I/O board and a modular small form factor computer. And and that way you can upgrade and share and do all the benefits that are described in the 2015 Rhombus Google keyword search for people watching here and anybody who wants to see it. Rhombus Tech Eco Computing white paper, an option you can put to 2015, but that will give you the search keywords that you need to find the white paper and find out a comprehensive 12,000 word essay on all of the benefits for all of the different perspectives which are involved in the chain behind mass volume computing manufacturing. Fantastic, I've got somebody wearing the t-shirt. Yeah, yes. Compute like nobody's watching, because now they can't. Yes, straight out of the thing. A bit of a piss take of Edward Snowden's thing. So yeah, very good. Thank you very much for bringing that. That's really fantastic to see. Now. So that's basically how and the what. Now, the status, the talk is about the update. So I've done a very brief bit about why, how, and what I'm doing. The updates are supposed to be my opportunity to communicate with you about what I'm doing and to present you with the opportunity. Present you with the opportunity to give me some advice and feedback, and also to reassure you that I am actually doing my absolute best in combination with your input and feedback and advice. So it is please, if you are following this project, please do either sign up for the ARM Netbook mailing list, the ineptly named ARM Netbook mailing list, or on the Crowdsupply updates, just so you can keep in touch and keep informed about what's going on. I appreciate they're quite long, but it is a very good reason for that. And it is for documentation of the project so that people who are doing another project sometime in the future can see what I did, why I did it, and what the result of that decision was. And the reason for that, why I am committed to doing that, is because I learned from the Open MoCo and the Open Pandora, and which in turn documented their projects in a similar fashion. So it's not just about me, and it's not even about what the thing. You may think, oh my God, he's written a 5,000-word essay as an update. It's for people who, in the future, who will have the time to and have a specific problem, which is exactly documented in these updates as how we went about solving it. So, solving the problem, documenting and solving the problem. So, it may go over some people's heads, but that's why I'm doing it. Now, the issues which I've encountered so far, starting with the first card, all right, this is back to 2010. I told the guys who spent $10,000, all right, said to these guys, please make me a card please look up the documentation on the schematic to make the card fit inside a 54 by, what is it, 86? 86, 90, whatever, I can't remember the thing. I'm supposed to know these numbers in my head. Whoops. Anybody know dimensions of PCMCA? I know the 54 one. Okay, let's call it 86, okay, whatever it is. I was saying, didn't follow my instructions and made the PCB 54 by 86 on the external dimensions. Fortunately, as a junior design engineer, there was a power management chip where there was a line, there was a pad here, and he didn't run the design rules check before sending it off to the Gerbers, off to the factory, and there's a short circuit between 3.3 volt and ground. The guy was so embarrassed, he wrote one reply saying, I'm terribly embarrassed, and if he'd been Japanese, he would have gone with the sword, you know, sort of committed harikiri. But luckily he was Chinese, and he just lost face rather than his life. His manager didn't tell him to go and jump off the thing. So they offered us access to their top engineer, who made the most beautiful DDR3 layout I have ever seen in my life. The EM interference from these tracks will be zero if there's everything. It was a fantastic. It was a work of art. It was $5,000, but it did actually work. But on it, it had. This was the version of the standard which had. Ethernet on it, gigabit Ethernet. And unfortunately, by about 2013, we had to change it to USB 3. Okay, so Ethernet out. It was also had SATA on it, so we took SATA out and put USB 2. But eventually, by about 2015, I changed it to USB 3 and USB 3 as well. So there's 10 gigabit per second in dual lane of two USBs. Two USBs, thank you, 10 minutes left. Two USB 3s, which gives 10 gigabit per second data transfer speed when cards are available, which will do that kind of transfer rate. So this here, 5,000. This here, this version was $2,000. Here was another $2,000. There's basically $2,000 a time to get 10 samples made up. Okay, but at this point I decided to stop, and I was not going to spend irresponsible amounts of money on doing PCB designs, and I would do it myself. Okay, so that's one other thing. So 17. Now, throughout all of this, we had TSS OP48 NAND chip up to about here. Okay, the TSS, the NAND, the speed of the NAND chips that are available, because it is very hard-coded specific, the A20 processor can only a boot ROM, not the actual thing. Once you get beyond the boot ROM, it's fine. But the boot ROM can only look at certain combinations of, looks for brute force attack and brute force search for certain combinations of speeds, capacities, and block sizes, etc., and error correction, ECC things. And by this time, 8 GB NAND flash, TSSOP legacy NAND, was not slow enough, not fast enough, was not slow enough to be accessible by the A20. Now, even Nintendo Wii, they were caught out. Nintendo were caught out by this problem. And the reason why, in around this time, that they stopped mass producing the thing is because the NAND chip wasn't available, right? So it's not just me. Not even the buying power of Nintendo could overcome the problems of the mass production of the legacy NAND stopping. So that had to go. It's another $2,000, an interesting thing. The other one is the HDMI port. We are onto the fourth HDMI port. The first one for Amphenol was a very good one. It fitted perfectly. That went end of life. Then the reversed one, same manufacturer, that went end of life 2 years ago. Then the Molex one that we found, tested that out, and couldn't get hold of it. It was a stupid mistake on my part, but no, I think. Finally, we've moved to one by Japanese aerospace engineering, JAE, and I've bought 3,000 of them. I bought 2 reels. I said, that's it, I'm not doing this thing again. I'm buying the reels right now. And the thing is, they're only 15 cents each, so it's okay. Monetary-wise, it's not breaking the bank. So these kinds of things, but it's the reason for those kinds of decisions is because it is such an unusual connector. Right? If it was a common part, if this was a single board computer, big one, I would be able to get top mount connectors, no problem. On the micro desktop, it's standard USB and standard blah, 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 and standard VGA. I can get those, no problem. There's 100 suppliers, different suppliers that can get exactly the same part. But these parts that I'm using, because it's mid-mount circuit board, it's very, very specialist parts. So cross fingers will be okay. The other thing is the DDR3 RAM. Right. Not a fan, Apple. Huge demand, insatiable demand for Apple devices. I apologize to all people who are in fact Apple fans and actually appreciate their work. I mean, it's fantastic, but the demands being placed on the component suppliers has actually caused complete stocks in the whole of Shenzhen and Taiwan to plummet to zero for all DDR3 RAM chips. Every single embedded computer supplier that only maxes out at a DDR3 is completely screwed. Hopefully, after Chinese New Year, the situation has got so bad that I think that all of the manufacturers have taken notice that their customers are screaming at them. And all of their distributors are screaming at them because the distributors' customers are screaming at them, give us a fucking DDR3 RAM! The situation should improve after Chinese New Year once all of these manufacturers are no longer contractually required to supply Apple with insane quantities of DDR4 memory. Okay? So that's it. How long have we got? 5 minutes left. 5 minutes left. I like to do things of handing people over questions, particularly for clarification. If anybody's got any questions, feel free to ask. If not, I'll sort of find some other random things to talk about. Any questions? Ideas? Okay. All right. Okay. So, what else should we talk about? So we've gone. Let's recap. We've gone over the how, why, and why, how, and where. why I'm doing this project, and also thinking the benefits and the environmental blah 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 things. I've described to you the history of the decisions that are uncomfortable decisions, including having to change the standard to suit a decade or 2-decade future lifetime of the standard. Some also uncomfortable decisions about having to remove components from the board because things have gone out of thing. This is all part of the course. Did anybody go to the component sourcing talk that I did yesterday? Yeah, you did. Cool, man. I apologise for your vision-wise. You've got things. Did I read out the URLs of the websites that I was doing? Yeah, fantastic. Taobao.com, panellook.com with one L, aliexpress.com. You do have to log into that. It's the only one that requires a login. And of course, DigiKey, RS Online, and all those ones you can use. But you use a combination of those resources to find the components. So that's good. So anybody's interested in that, the talk is online, etc., etc. So you'll be able to review it. What else can I think? Future products that for future designs. Bear in mind that I am the guardian of the EOMA68 standard. Under the rules of certification marks, I am not permitted to sell products. Okay? If you are a developer, you can contact me and you can come over that line and work with me to reach people. Okay, and help me to write documentation, do kernel porting, do this, improvements, patches, etc., etc. So that way I can get you access to a board early, but otherwise, unfortunately, it's a no, because I really cannot cross that line of competing with businesses who might wish to be the ones that sell you products. So that explains in part some of the thing, because also I've kept this project at the techie phase mailing list, not forum, yeah, because I wanted specifically to make it clear to people that this is not yet fully user ready, if you know what I mean. And that's very important, so that the people, if we've got 1 million people buying this right now, all of us, me included, would be totally overwhelmed. There would be complaints that EOMA68 is a failure, and the standard would be dead. Right? I think with the past 6 years would be completely wasted. So there's a very deliberate reason why I am going steady, slowly, and I think because I am thinking about planning for the future. It's like being the technical director of WC3 standards organization thing. It's like, thing, except I don't take bribes. And I don't take money which is claimed to be a sponsorship to insert this DRM thing into the WC3 standard. You know who you are, Tim. So I put this thing. Yes, question.
Yesterday, just right before your talk on the supply of electronic component supplier, there was a talk about the Olimex project for doing an open source and PCAT-based laptop, which has some kind of same goals that you have. You want the system to be module-based, so you can replace parts and so on. Have you be in touch with them, or you're aware of that project? Because your board could have been the main CPU of this laptop also. Sorry.
It's okay. I have to be careful how I answer. The question was, why am I not collaborating with Olimex on this project? I cannot publicly discuss it with you for fear of harming the reputation of the EOMA68 project by having to publicly disclose to you some of the. No, I can't talk about it. Okay, all right. I can talk to you privately about it. That's not a problem, as long as you don't, start blogging about it, etc., etc. Yeah, you will find you will see the consequences of Svetan's actions and decisions eventually. Okay. All right.
What's the timeline for the production? So you started the production of this.
Right.
What's the timeline of for the people that have crowdfunded you?
Okay. Right. The answer really has to be when it's ready. It would have been fantastic to have been at the phase where I am now, where the production testing, pre-production testing, was done, blah, 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 blah. But the rules for crowdfunding are you must have a working prototype before you can go to the things. And I'm sorry, I must apologize. I did have a working prototype. It's just that the things that you deal with components going end of life and blah, 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 et cetera, et cetera, et cetera, and getting guaranteed supply, you can't, it's not like software where you can release it and fix it afterwards. Hardware, one mistake, you got a short circuit like those guys had here, the board won't even boot up, it'll catch fire. Okay, hardware is very, very different. You have to get it right. And here it's even more complex. It's the software collaborates with the hardware. So I have safety issues to consider, which are in some parts is taken away in an extreme way of just if the current goes over a certain limit, the hardware, the board, the system is permitted to just cut the power. No notification, nothing. Right? Overcurrent protection, it's cut in, it's in microseconds, bang, it's out. Your card is offline, no power. So these are kinds of things that I have to think about and make sure I think. Now, to answer your question specifically, now that we have done the pre-production prototype, the PCBs have been done. Mike is now buying the components. He should have everything by about end of February, with the exception of the DDR3 RAM. Okay, we'll have to work out where to get the DDR RAM from. Now we're probably up to about March. Okay, once he's put that on and sent them to me, it'll take me about 3 days to get to me wherever I am in the world. I will test it. I will give him the green light and say, go, buy 1,000, 4,000, 5,000 components right now. Okay, he's already got the cash in the bank to do it. Okay, so from there, he will then be able to describe to me exactly what the expected schedule is of his factory, and that will be a formal process that will be easily predictable. So apart from hiccups and stuff like that, there will be no unknowns or unknowable unknowns is the thing. You can't know what you don't know, what you didn't know that you didn't know in order to be able to fix the thing that you didn't know. Yeah, that was the previous pitch situation. All of those things, apart from the fucking DDR3 RAM, blah, apart from that, are all fixed. Those are all in the past now. As long as none of the components go end of life, no. Cross the fingers and everything else. Okay, yeah. So maybe June, July. Plus DDR3s. Yeah.
Have you talked to the Linux Sunxi team about porting parts of the kernel to the A20 processor for this board?
The question is, have I talked to the Linux SunXi team about the A20? No, because you will find out why. The SunXi team did not consult me before moving to a Google group, which I think they abandoned. Read between the lines here. They en masse moved from the resources that I was doing and from helping me and collaborating to SunXi, Linux SunXi Wiki, and to the Google groups. Yeah. So I can't talk to them. Privately, I can send them email and they will maybe do something. But it turns out that actually the there's two branches. The stable one that works with 100%, known works 100% with all the hardware of this card and the thing, is the 3.4.104 plus kernel. And unfortunately, there is stuff still missing from the hardware which would stop some of the capabilities of this card from even working. So it's like, why would you go to a mainline kernel when you can't actually connect stuff that is really important for the customers and for people to actually use? So when that is done, because it will work with everybody else's cards and computers and single boards, I will just be able to cut over that and make a release, and it will probably actually work with the Debian straight out of the thing. But there is the do you know 96 boards and the Beagle boards problem? Yeah, of the shields. The shields have to actually have their own device tree, which you then have to patch in at runtime after you've booted and detected what the shield actually is. And that is what the EEPROM is for on the housings. It's part of the EOMA68 standard. It requires that there be an identification EEPROM on the housing, every single one of them, at a fixed known address on the I2C bus, which must not conflict with any other device. So it's 0x51 for the address to read that EEPROM. So it's part of the standard. You cannot put any other device on address 0x51 because it will be a problem. So being able to read that, we can then find out which device tree fragment for that board should be inserted into the kernel of the thing. And that is where I will need assistance from people, from volunteers, to help to write those things, and also kick the Linux mainline people to actually put the device tree patching, dynamic patching system into mainline. But again, doesn't necessarily need the Linux SunSI team to do that, because it's a mainline thing that it can be handled by Linaro, can and will be handled by the Linaro team, the BeagleBoard team, this and that thing. So it's an important thing for all of these boards, which, incidentally happens to be useful for this. Yeah. So yeah, cool. Thank you very much, guys.